Okay, so for the do now, you were expected to do, you were for the first task, you were expected to write each polynomial in standard form, okay? So you have to write this one in standard form. So to write something in standard form, what are you supposed to do? This should be like, a review. I just talked about it with you guys. I mean, even though it was only for Amina, I told it to you guys. So what do you have to do?
Add the exponents.
Oh no, that is
Wait,
not.
multiply.
No. You have to write this in standard form, right? So
it is 5x squared and then plus 4.
That is so correct. Yes. That's because remember in standard form you have to start off like the term that has the highest exponent, you have to put that in the first place. So look, this term right here, the 5x in here, I'm going to use a different color. The 5x in here, this has an exponent of 2, right? Look at the 2. So then this term has a degree of 2, right? So this is a second degree term. But how about this one? What is the degree? What is the degree of this term?
1.
1.
No, 0.
Yeah, what?
1.
Yeah.
Zuri, if you have to say something, you want to say something?
0.
Yeah, 0. I mean, I'm actually gonna show it to you in here. So this is the 4, right? What I essentially mean is that this 4 actually has a variable to it. So like, let's say x is the variable that 4 has, and the exponent that x has is 0. Remember, guys, anything to the 0 power is what? Hold on. Anything to the 0 power is what?
Itself.
So what? Amina said something.
Anything to the 0 power is 1, right?
Yeah, it is 1. So anything to the 0 power is equal to 1. It's like an universal rule of exponent. So then what does this turn out to be? 4 times x to the 0 power is what? 4 times, what is x to the 0 power? Right, so 4 times 1 is 4 essentially, right? So then the degree that this term has is actually 0. I told you guys this for like the people who attended yesterday's class. I told you this. Remember, all the non-zero constant, remember, non-zero is the word in here, because when we were doing the quiz yesterday, there was one question that what is the degree of this, so this is actually 0. What is the degree of 0? What is the degree of this term? Zarif, what is the degree of this term? We did this yesterday, remember in the quiz? The 0 that I wrote in top.
The 0.
Yeah, what is the degree? What is the degree?
0, none.
None. None is the degree, because remember, even though this is a constant, it is not a non-zero constant. It is a 0 constant. So all the non-zero constants, I'm going to write here non-zero constants, right? They have a degree of 0. But if it is 0, then it does not have a degree. It's just none, plain none, nothing, okay? So for this 4 right here, I'm going to clear. Okay, so for this 4 right here, this has a degree of 0, and 5x squared has a degree of 2. So like, then which one is greater? 2, right? So then we put the 5x squared in front plus 4. That is A. So then let's do it for B, like B, A. Well, how do you write this in standard form? Guys, you can private message me, public message me, or you can unmute yourself and answer. I do not mind.
It's negative t cube. Then plus 2 square.
T squared. Yup, Amina, that is correct. And then what? And then what?
And minus 10t.
Good job, guys. Yes, that is the correct standard form. I liked how both of you guys said negative t to the 3rd power. You have to carry the sign with you. Whenever you move a term, you have to look at the sign that it has in front of itself, okay? So yeah, that is the standard form. How about this one?
Doesn't it stays the same?
It does stay the same because it is a monomial. You cannot you cannot swap it with anything. You don't have to rearrange this one. It stays at itself, okay? So then let's go to B. What is B asking us to do? You have to identify the degree. What is the degree? So when it's usually asking you to find the degree, it's usually asking you to find the degree of the polynomial, not the term. So what is the degree of this polynomial in here? It's actually a binomial, but yeah, what is the degree?
4.
4 is the degree?
3.
3 is the degree? Is
Wait,
it?
for the whole thing?
Yeah, so remember, I told you. So degree of a polynomial is essentially like the term with the highest degree. So whichever term has the highest degree, that is going to be the degree of your polynomial. It's not a term that I'm asking you for. I'm asking you for the degree.
So it's 2?
Yeah, it's 2, right? It's a second degree binomial. God, second degree binomial. Because look,
Wait, why is it 3?
why is it 3?
Why is it not 3?
Oh, why is it not 3?
Because of minus sign?
Where do you see the minus sign?
Wait, are we not talking about B? Like
Yeah.
T?
No, I'm talking about like, okay, so this is a little confusing and I do apologize for that. So it's like A, B, C. At the top, do you see those? A, B, C. So I'm talking about like alphabet A, but then I'm doing like option B.
Oh, so we're still doing for A. Oh, okay.
I'm sorry, I should have put like numbers instead of like alphabets in both places. I'm sorry for that. Yeah, so we're doing like B, like the task B in here, okay? So then it is a second degree. How about this one? What is the degree of the polynomial?
Third
3.
degree?
Yep. How about this?
3.
Like,
No,
no.
it's not 3. It's
Third
6.
degree.
So what?
6.
Yes.
6 degree.
Yes. And I believe Amina was saying the same thing. So it is 6 because 3 plus 2. Remember, for you to find the degree of a term, you have to add all the exponents. If you add all the exponents, you get the degree of the term, which is 6. Great. I'm impressed. How about C? Like task C. You have to classify each polynomial by the number of terms. I already told you guys this, so please just get it right. I already told you what is this called, what is this called, and what is this called. What is this called?
Exponents?
No. Like in terms of polynomial, like what kind of polynomial is this? I'm gonna use different colors so it gets easier for you to see this. What kind of polynomial is this? Yes, it's a binomial because it has only 2 terms. How about this?
Which one?
The
Trinomial?
Trinomial.
Uh-huh. Thank you, Jim. Trinomial, and thank you, Amina, and obviously thank you, Zoe, for participating. How about this one?
Binomial?
Binomial.
I think
Wait,
it's
it's not
monomial
binomial.
something.
Yeah, it is a monomial. There we go, because it has only 1 term, right? The y to the 3rd power, x to the 3rd power, they're being multiplied to the 8. So it is a monomial, right? So it is a monomial. Okay, so I'll have to clear it because I'm using the Zoom thing. Okay, so now we're actually gonna do subtracting polynomials here. Whew. Okay, so we are gonna learn about subtracting polynomials today. Okay, so subtracting polynomials is actually very similar to adding polynomials in terms of the fact that you have to combine the like terms, okay? But before you actually go to combine the like terms, there's one thing that you have to do. That is like an extra step that you have to do. Do you guys see how like this expression, okay, I have to use a different color, red, okay. Do you guys see how this is an expression right here, and then this is an expression right here, and they're being like subtracted from each other? Yeah, they're being they're being subtracted from each other, right? So then here is the tricky part. What you have to do is like you have to distribute this subtraction, so this subtraction sign into each of the terms that is inside the parentheses. So what you have to do is like there is actually an imaginary 1 in here. Oh God. So there is actually an imaginary 1 in there, right? So there is actually an imaginary 1 in here. So you have to multiply each of the terms that you see in here with that negative 1. What happens when you multiply a number using a negative number?
It become the opposite sign.
Right. So essentially, it remains. It like it prevails its like identity. So it like remains the same number, but then just the sign changes. It just becomes the opposite sign. So you are gonna bring down each of this term that you see in here, but then it's just gonna be it's just gonna have the opposite sign. So look, 5x squared comes down in here. 3x to the third, it comes down in here. 8x comes down in here. 7 comes down in here. But look how this was like positive 5x squared, right? It becomes negative. And then this plus becomes negative. This negative, like minus, becomes plus. And this plus becomes negative. This is like an extra step that you have to do if you are subtracting like a polynomial, right? Please remember this, because if you do not do this, you are going to get a whole different answer, which is wrong. Okay? So once you do this, once you distribute this negative sign into each of the terms that you see in here, it is an easy go. Okay? So now what you have to do is like you have to combine the like terms. Okay? And I just told you guys even in this video that in order for you to know if these are like terms, what you actually have to do is that you have to look for the exponent and the variable. So if they have the same variable and the same exponent, boom, they're like terms. Let's go with the first one, okay? 5x to the fourth. So we have to look for another term that has x to the fourth power. Does any of the terms in here have it? No, right? No. So this stays by itself, so we're just going to bring it down in here. How about the 2x? Does any of the other terms in here have x to itself? Just x and no exponent. Yes, 8x. Look, you can also follow the arrow. And how about 6x squared? So we have to look for another term that has x squared to it. What is it?
Negative 5x.
That's so correct. So we are gonna bring this down together. So how about the 12? Do we see any of the non-zero constants, just like plain numbers and nothing to itself?
Negative 7.
Yep, negative 7. So we are gonna bring each of them together in pairs so that you guys can combine them easily. Okay. So okay, but look, did we leave any numbers out in here? So we did this, we did this, we did this, this. Oh, we did leave this one out. How about this one? Does it have pair, like any of the like terms in here?
No.
No, it doesn't. So we are gonna just bring this one down, okay? But look, I did something in here. What did I do? What did I do, Zarif? I told you this yesterday. What did I do?
You combine the like terms?
Yeah, but I did that, but then you know how I was just like bringing all these terms from here down. So
you
I was just like
added the
no, look, I'm giving you a clue. Hold on, look. You see how like I'm bringing all these numbers, and so I brought down the 5x to the fourth. But then what did I write after that? Isn't after 5x plus 4 like 2x? Then where did this come from? And why didn't I write 2x and instead wrote 3x to the third, negative 3x to the third?
Isn't it like a standard form?
Yep. So when I'm trying to like combine the like terms, so I'm like putting the like terms like side by side, what I'm essentially trying to do is like I'm trying to like arrange them in standard form. So once I put like, I'm trying to like, look, I tried to put this and then I tried to put the other term with the second highest exponent. So once you're like trying to combine, if you do this, like if you bring down the numbers in like, not the numbers, but the terms in with descending exponents, and if you set up your step like that, it's going to be really easy when you do your answer, like when you simplify. Otherwise, if you just like randomly bring down pairs, you have to do an extra step of arranging your answer in standard form, because after every single algebraic operation you do, you are expected to leave your answer in standard form. Okay, so this is just something to like save you some time. So then I try to combine. You guys know how to combine obviously terms, right? So this comes down by itself right here. This comes down there, and then this can be combined to this here. This can be combined to this here, and this can be combined to this here. Okay, so that's how I simplified my answer, and it cannot be simplified any further, and I left my answer in there. Okay, any questions so far? Do we have any questions? No questions? Okay, I'm gonna see if we have any questions or not through our practice problems. Okay, I also have another video in here. So essentially what I do is like after each lesson or like sub lessons, I have a video for you guys, but I'm not gonna play that video for you in the Zoom session of ours just because it is like a little like time consuming. So this is just for you if you guys feel like you need like some extra help. Other than the Zoom session, you can always watch this video and then, you know, get a little bit of better understanding, okay? All right, so we are gonna, okay, no, we're gonna play a game first. Okay, so we are gonna play the game first. Okay, so how many students do we have here? This is Jeopardy. I believe we have 3 participants, right? Amina, Jim, and Zarif. Okay, so I'm gonna set up like 3 teams. Yeah, it's already set up there. And you guys will be in like 1 person a team just because we don't have that many students, and we're gonna play Jeopardy. Yeah, you guys wanna do it?
Yeah.
Yeah. Okay. So this Jeopardy, it actually has all the things that I have covered so far. So like terms, adding, subtracting, degree, standard form. I taught you guys all of this, right? So then, yeah, this is how it's gonna go. So yeah, who wants to go first?
I wanna go.
Okay, I'm gonna rename this. Okay, how do you spell your name? Z-A?
Zarif.
Okay, gotcha. God, I don't know what I did. And I have Amina, which is, I believe, Amena. And then I have Jim. Okay, guys, go. Zarif will go first. So pick.
I'm gonna go like times 300.
I.
Combine like terms minus leave answers in standard form.
That's not minus. So you were asked to combine the like terms, and then you were supposed to leave your answer in standard form.
Oh, okay.
Yeah, this is something that I didn't actually teach you guys yet, but you should be able to do it. If not, then I'm obviously going to show you how to do it.
So I put the, so it's, is it 6 square cube, then
Okay, I want you to try it by yourself first. I'm going to give you like a minute, and then if you get the point, you do, and then we are going to go for it, okay, together. Just because I want the thing to like serve its purpose, like it's a game because of that.
okay, I got the answer.
Okay, what is the answer?
6 square cube minus 9x plus 8.
Okay, hold on for 1 second. So you said what?
6 cube, 6 square cube.
6 squared cube?
I mean,
6x cubed?
yeah, my bad. I keep getting confused with the words.
It's okay. And what?
Minus 9x
Uh-huh.
plus 8.
Okay, let's see if that is the correct answer. That is the correct answer. So how many points am I supposed to give you? 300. Yes. Okay. Amina, you are next. Go.
I'm gonna go with adding 100.
Okay.
Okay, give me 1 second.
Yeah, I'll give you a minute to do it.
It's 5x minus 1.
Yup. 5x. Oh, hold on. You said 5x minus 1?
I mean positive 1.
Yeah,
plus
yeah.
1, sorry.
Yeah. That is the correct answer. 5x. What? No, it should be plus. I don't know why they said it's minus. It has to be plus. I'll just give you the point. Because it's plus, right? Like 2 minus 1 is 1. I'm not being paranoid.
Yeah, because there's like plus 2, and plus 2 is bigger than minus 1.
Yeah, you're just subtracting 1 from 2, so I don't know. Yeah, and then Jim is next. Jim, you can either unmute yourself or you can like message me. Subtract 100, yes. Go. subtraction and addition, they actually have the same points, but then subtraction is kind of like relatively harder than addition. Okay, so Jim said 19. Is that what you said?
What about the x's?
He said 19, so I'm just gonna write his answer. And Jim, are you sure it's 19? I mean, it's okay. I'm just gonna give Jim the point because he tried. Okay. Okay. I'm gonna explain it to you guys why it is not what Jim said, because look, you have
Isn't
to.
it? There's gonna be only one x.
Yup. So yeah, Jim actually said 19, but it's gonna be okay. So you have to combine the like terms of this and then this. They're like terms. So 2x. Remember, guys, this is not like okay. So there is like a second step that you guys should do. So this is like 2x plus 15 minus x and then minus 4. Okay. So then combine the like terms. 3x plus 19. Okay. So combine the like terms. So 2x minus x, what does that give you? Jim, what does 2x minus x give you?
3x.
Oh no, it's not 3x. It's
It has
like,
subtraction.
yeah, it's like,
Because of
look.
Oh, okay, 1x.
Yeah, it is just x. Yeah. It's like, it's essentially 2 minus 1. Because, you know, if you just disregard the x's, it's just like 2 minus 1. And then 2 minus 1 is just 1, which is just x, okay? And how about 15 minus 4?
11.
Yeah, it is 11, right? And then it's positive 11. So the answer should be x plus 11. Yup, it is x plus 11. So look, I think what you did, you forgot to like distribute the negative sign. But remember, you have to distribute the negative sign. You cannot just combine the like terms from here and then from here and just call it a day. No, you can't do that. You have to distribute the negative one that you have in here before you actually combine that, okay? But good try. I liked it. Thank you. We are gonna play 2 more rounds, I believe. Okay, go. Very again.
Subtracting 400.
Yes. Okay. You are like at 300 though. That's good.
Okay,
Okay,
let
so
me do it.
I'm gonna give you a minute, even though this looks a little harder than the other ones, but I'm still gonna give you a minute. It's 36. Do you have
Okay, I got the
anything?
answer.
Okay, which is
Minus 14x squared plus 4.
plus 4.
Yeah.
Okay, let's see if that's the answer or not. That is the answer. Oh my god. Amina, go. Hold on, go.
Yeah, okay, I'm gonna go with 500 adding.
Adding 500. Okay. Ooh, it's a big one. We have a polynomial being added to a trinomial. And I'm going to give you a minute again.
So the answer is 2x squared plus 2x. Wait, hold on. Wait, 1 second. Yeah, so the answer is 2x squared plus 15.
2x squared plus 15.
Yeah.
Okay, before I actually show you the answer, what do you think? Is this the correct answer? What happened to like x to the third?
It cancels out because there is negative 3x.
Right, it does. Okay. Yes, that is the correct answer. Oh my god. So you got it. Jim, you are next up. Go. Hold on. Go. Again, you can text me if you want. I meant, yeah. Subtract 500. Yes. Okay. Whew. This is another big one, but even harder. It's been a minute. Do you have anything for us? I believe Jim is like typing it out, so we're gonna give him a little bit more time. Jim, are you typing it out, or should we go over it? I kind of messed up. Oh, it's okay. It's okay. Don't worry. Don't worry.
Can I say the answer?
Yeah, sure. Oh my God.
It's 0.
Oh, it's 0. Oh my God. It is 0. Oh no. It looks so big and so confusing and so scary. What happened? Okay, so I'm gonna show you guys. So this is a polynomial. This is not a polynomial. But look, guys, look. Wow, I got that answer. Oh, so I'm gonna give you the point. 600. There we go. So look, they're like terms, right? So Amina was actually able to go a step further, and then she was able to see it that they're like identical and they're being subtracted from each other. So what happens if you subtract 2 from 2? You get 0, right? So if you're subtracting 2 identical things, you get essentially 0. But if you are not able to see that directly, you can do the sub step. So like, you know, you have to write it out. 3x minus 3x squared minus 3x to the third minus 3x to the fourth. And okay, this was not a good idea. Minus 3x. Remember to distribute the negative, okay? So distribute, and distribute, right? So negative 3x, and you have plus 3x squared, and you have plus 3x to the third and plus 3x to the fourth. Okay, now we're going to combine like terms, okay? So 3x and then minus 3x, so positive 3x, negative 3x, they cancel out. Bye-bye. And then you have 3x squared, right? And then another 3x squared, but this is negative 3x squared. So negative 3x squared plus 3x squared, they cancel out. Bye-bye. So negative 3x to the third, and you have plus positive 3x to the third, they cancel out. And then you have negative x to the fourth and plus x to the fourth, they cancel out. So if you do not see that directly, that they're like literally identical things subtracted from each other, you can do this sub-step and figure it out that the answer is essentially 0. Okay, so now we are gonna jump into the last operation that I plan to do with you guys. Okay, so I do have some practice problems, but we're just gonna wait for that towards the end, okay? All right.
So did I win?
Oh, you did. Oh my God, you did. You were at 700 and our other 2 participants were at 600. You did. Oh my God. Okay. So about multiplying polynomials, it's actually not that bad. So something we have to know first is the product rule. Okay, so this comes again when you do the exponential laws and the rules of exponents. But for multiplying, you have to know this part. When it comes to like exponential rules, this is like just part of a bigger thing. But then in multiplying polynomials, you should just like itself in here. Okay, so look, when you have the same base, like look, this is an x. This is another x. When you have the same base but with different exponent, right? You can keep the base and add the exponents, right? So this is something that you need to know when you're like multiplying polynomials, okay? And the same thing in here, right? Essentially, this is like multiplication, but then you just have parentheses around the terms, right? So n to the x power and then n to the y power, these are your same base. They have the same base, right? So you keep the base and then they have different exponents. So you add the exponents. Okay? Any questions so far? Okay. And that was the product rule. So I'm gonna go over the power rule right now, okay? So what the power rule states is that when you have a variable raised to the exponent and that is being multiplied by another number, so like a variable with an exponent that is being multiplied by another exponent, you multiply the exponents, right? So you keep the base, so whatever the base was, x was the base, so you keep the base and you multiply the exponents, okay? So you multiply 3 and 2 and you get 6. It's the same thing in here, right? So you keep the base right here and you multiply the exponent. This time our exponent is not a number, it's a variable rather. But you multiply the exponent. So x times 3 gives you 3x. So you keep the base, multiply the exponents. That is what the power rule states. Any questions? Okay, so I do have some practice problems in here for you guys, and we are going to do this together, okay? So for the first one, I'm going to give you guys 30 seconds to like try it, and then you guys can private message me the answer. For the exponent, you guys can use the little caret sign to show that you are indicating an exponent.
Wait, how do you put the exponent thing?
Are you using your phone or a computer?
Computer.
Computer. It's okay. You can just type the.
There is the arrow on 6.
Yeah, on top of the 6, there is a caret. The caret sign. Yeah, that.
So like I'm just gonna put that. So like to
Yeah, after the variable. Yep.
All right.
Jim, are you gonna type me the answer, or should we move on? Okay, guys. Let me actually show you guys this, okay? So this is a little confusing given the fact that I told you the product rule and the power rule at the same time. And you guys are like, when are we supposed to multiply and when are we supposed to add again? Okay, so basically, if you have two terms that are being multiplied together, like you can present multiplication in different forms. So you can have like a dot in between. You can have like two parentheses covering them, but it's the same thing. You're multiplying, okay? So you are multiplying two variables. The first one has an exponent of 2. The second one has an exponent of 3. So the product rule states when you are multiplying two variables, right, or two terms with the same base, you keep the base. So I'm going to keep it x, and you add the exponent. You add 3 and 2. What is 3 plus 2? 5. So x to the 5th power is the correct answer. Okay.
I got that.
Yes, you guys did. Oh my God, I'm so happy. Do the second one. Good job, Amina. Oh my God, I spelled your name wrong. It's Amena. Is that how you say it, or Amina?
It's Amina, the way you were saying.
Right, but then I put 2E. I'm so sorry. Try it one more time, Zarif. Remember, guys, you are keeping the base, right? So you keep the base and you add the exponents. You add the exponents. Remember, we just learned about how to add polynomials. We did like a Jeopardy too. So add the exponents. Okay, I'm going to go over it with you guys, okay?
Wait, let me finish it real quick.
Okay, sure. I'm sorry. You were right, but you were just like a little bit like, okay. No.
It's not.
No.
There's a -1 in it.
No, you look, the thing that you were doing wrong, you had the correct non-zero constant, right? But then what is x plus x?
Oh, I forgot. 2x.
Yeah, x plus x is 2x, right? But then you just had x, so sorry, you know?
My God.
It's okay, no. So you keep the base, which is n, and then you add the exponents, right? So 2x, x plus x is 2x, and then 2 minus 1 is just plus 1, right? Try the second one. I mean, the third one, I'm sorry. Be quicker. Something should ring a bell in there. Oh. Yeah. Okay, guys, this should come. Okay, you guys ready to get surprised?
Wait, did I get it wrong?
Yeah, you did.
Can I try it again?
Yeah, you can. But look, but no. Okay, let me show you something. And then you ready to get surprised? Okay.
Can you multiply x and y like that?
You can't combine them.
Wait, is it x A3
So it's
like
nothing.
exponents.
You just leave it like that.
You leave it like that, exactly. But I like how you guys tried. Oh my God, thank you so much. So you see how, remember for the product rule, right? Okay. For the product rule, you have to have the same base, right? You have to have the same base. You cannot combine something that are of different bases, okay? You cannot do that. All right? So yeah, now you got it correct. So you leave it like that. That's it. This is the answer. That's it, right? X to the power of a plus 3 times y to the power of a. Yes, it is tricky. Y to the power of a plus 4, and that's the answer. That's it. You cannot do anything to it. That is the answer. How about this? Try this. This one's in here. The power rule. Okay. I already have some answers. Good job, Amina. Good job, Zarif. Good job. Amina again. She tried both of them. Yeah, good job, and you got both of them correct. Okay, so let me just okay, Jim. Are you gonna try the yes, thank you, Jim. Good job. You got it correct. Zarif, good job. You got it correct for the second one. I'm gonna go over the first one just because, okay? So then you guys had it right, okay? You guys had it right. So I'm just gonna have the base intact, and then I'm just gonna multiply the exponent. So it's a times b. And the second one is the same thing as the first one, but it's just like instead of numbers, instead of variables or like alphabets, I have numbers. So you multiply them. 4 times 2 is 8. That is the correct answer. And you guys got it correct. I'm so happy. You guys are making me so happy. Okay. So now we are going to learn about something a little different than this. Okay, so we are actually going to learn about how to multiply using the FOIL method. I'm not sure if you guys have learned it in your 8th grade Algebra 1, but this is something that is taught in Algebra 1. But I'm going to teach you guys, or I'm going to walk you through this again, okay? So for the FOIL thing, I know it's like, it shows you 1, 2, 3, 4, 5, 6, 7, 8, so many steps, but it's not that complicated, I promise. It's not, okay? So
I remember doing it, but like I did it like, do you remember Mr. Ang from 8th grade?
Oh, I did not have that person.
Okay, anyways, but he taught us like a F. He put like FOIL, and like then I made it like made equations with the F, then the O, then the I, then the L. Everyone thought it was hard, but for me it was the most easiest because that's how I understood it.
It is actually easy. I agree with you. It's the easiest type of multiplication method, right? So what do you essentially? Okay, it sounds confusing, Amina, but here it's not confusing at all. I promise. Look. So you see how like these two terms, not terms, yeah, these are like two terms. They're being, not two terms, I lied. You see how like this thing is like being multiplied to the other one, right? So this actually, okay, yeah. So what we're gonna do is like we'll look at the first term, 3x, and we're gonna multiply it with the first term in the second parenthesis. So what is 3x times 2x? It's 6x to the 6x squared, right? And then we're gonna attack the second number in the second parenthesis, right? So 3x times 4, that gives you 3x times negative 4 gives you negative 12. So you have already 6x squared from the previous multiplication that you did, and now you have negative 12. You just keep building on, right? So now you're going to use the negative 8 you have, right? So negative 8 times 2x is negative 16. So, and then you write that. Remember, you're just adding on to the previous ones that you just did. And now you're going to multiply negative 8 to negative 4, and you are supposed to get positive 32. Once you get this, you are supposed to see if you have any like terms. 6x squared, no other x squared in this expression. So you can't combine it. Negative 12, you can combine negative 12 with negative 16. Negative 12 minus 16 is negative 28, and a 32 remains by itself. Okay, I believe Amina is still confused, but here's what I'm gonna do with her, okay? I'm gonna make, you got it? Okay, so since, how about Jim? Jim, you good? Did you understand? Yeah, okay, so we all did. It's a green light then. So we are gonna see if we actually understood it or not using the practice problems. So we are gonna attack the first practice problem we have in here. So try this one, guys. Try to do this one, number 1 in here. And then private message me the answer. What is the answer for the first question? Good job, Amina. Amina, you can try the 4th one that we have in here, because that's going to be the second question that we're going to do for today. Good job, Zarif. Okay, so I'm actually going to go over number 1 with you guys, okay? So what do we do? So it's asking you to find the product of 3x minus 5 and 3r. So if I want to write this in mathematical expression, this is going to be what it should look like. 3r times 2. Zari, if you can try number 4 if you want. 2r squared minus 5. Okay? So we have 3r, and then we are multiplying it with 2r squared minus 5. So what I have to do is, like, I'll have to distribute, okay? So I'm going to distribute this. I'm going to distribute this again. So I'm going to multiply this term that I have in here with 3r. And I'm going to multiply. So I'm going to multiply this with this. And I'm going to multiply this again with this. So I'm going to multiply 3r with this first. And then I'm going to multiply 3r with 5 again. So what is 3r times 2r squared? That should give you 6r to the 3rd. Because remember, this is what I just told you guys about the law of exponent, right? The product rule states when you're multiplying, if you have the same base, so essentially 3 times 2 gives you 6. And if you have the same base, or like r and r, you keep the base and you add the exponent. There is an invisible 1 in here, and you add the exponent. 2 plus 1 is 3. So it's 6x to the 3rd. And 3r times 5 is actually, 3r times negative 5 is actually negative 15r. This is your answer, which is option A. Okay, for number 4, try it one more time, Amina.
I don't get number 4.
Okay, it's giving all of us a problem. Okay. I'm going to show you guys, okay? Ready? All right, let's go. So what I'm going to do first is that I see there is an exponent in here. Okay, so what I'm going to do is, like, I'm going to try to get to that exponent first before I distribute the 2 and then move on. Okay, so I'm going to keep the 3 in here. And x minus 2 squared is actually x minus 2 times x minus 2, right? We understand that part? Okay.
Can we write it as like x squared minus 4?
X squared minus 4, like write x minus 2 squared as x squared minus 4, like that? You can't do that, because this is not equal to this. X squared, x minus 2 squared is not equal to x squared minus 4, because this is what you guys are doing wrong. And you know, this is like this is the easiest way to figure this out, that you're doing it wrong, because you just told me that x minus 2 squared is equal to x squared minus 4. Plug in a number, plug in 1 for x. So what do you get? 1 minus 2 squared.
Oh, so is it like x squared minus 2? Okay.
So then, do you get the same number? Because 1 minus 2 is 1. Is that equal to like negative 3? No, that is not. So you are not doing the same thing. If I know these laws of exponent, they're like super confusing and they always get you. if you ever seem to like, not understand, or like if you're not 100% sure, I always tell you to like plug in a number and then see if they give you the same result. If they don't, then don't try it, okay? So what that actually, x minus 2 whole squared, what this is actually is you're multiplying x minus 2 twice. Okay, there is actually a formula that, not necessarily a formula, but a thing that I don't know if you guys know it. It's like a minus b whole squared is equal to a squared minus 2ab plus b squared. This is like the formula for like if you are subtracting two numbers, and then if the sum of the numbers that, I mean, if you're like subtracting two numbers, and then if you are raising the result to the second part, that is what you are supposed to get. But I'm gonna see how this holds true. So x times x, so we are like multiplying this, right? So what we're gonna do is like we are gonna multiply x with this x first, and we're then gonna multiply x with this 2 first. So now we're done with this x, right? And then what we're gonna do is we're gonna multiply this x with this x, and then we're going to multiply this x. I'm sorry. My bad, guys. So then the next thing that we should do is like we should multiply the negative 2 with the x here, and negative 2 with the x, with the negative 2 in here. Okay, so what is x times x?
X squared.
And then what is x times negative 2? Negative 2 times x is, because look, now we're done with the x, right? Now we're done, and now we are going to multiply this negative 2 with these two terms here again. So negative 2 times x gives you negative 2x, and negative 2 times negative 2 gives you positive 4. And then look here, guys. Do you see like terms? Yes, I do. Negative 2x and then negative 2x. I'm going to combine them. X squared minus 4x plus 4. Right? This is the expanded form of this, right? So look, I just told you guys about this rule, right? Look how it's the same thing. Instead of a, you have x squared minus 2ab. So like 2 times, this is your a, this is your b. So 2 times 2 is 4, times x is like 4x, and then plus b squared, which is like 2 squared. If you guys don't know this formula or just don't find it easy to use, you don't have to use it just for you. This is something that people use for their own convenience. But then if you don't want to, you don't have to. You can always expand it. You can always do this thing that I just did here, this, and then you can always find the expanded form. Okay, but then this is just one of the steps in here. Okay, so I'm gonna write it here. So now we kind of like expanded this part. Formula is easier, Amina? Okay. So then you can use the formula if you want to. If you don't want to do this step of like combining each other, you don't have to use the formula of a squared minus 2ab plus b squared. So then look, 3 times x minus 2 whole squared. We have the expanded form of that. It's right here. So I'm going to write that in there, right? So it's x squared minus 4x plus 4, right? And then I have negative 2 times x minus 1. What is the next step that I should do? I should distribute the 3, and distribute the 3. I should distribute the negative 2 into x and then negative 1. So 3 times x squared is 3x squared minus, 3 times negative 4x is negative 12x. 3 times positive 4 is positive 12. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 1. Now we combine like terms. Do I have any like terms for 3x squared? No, I don't. So I'm just going to bring it down like that. Do I have any like terms for negative 12? Yes, I do. I have positive, I have negative 2x. So negative 12 minus negative 2x is what? Negative 14x. And do I have any like terms for the non-zero constant 12? Yes, I do. I have positive 12 and I have positive 1, which is what? I'm sorry. This should have been positive 2, because negative 2 times negative 1 is like positive 2. So like 12 plus 2 is positive 14. Does it match up with any of the answer choices we have? It does. D is the answer. It was a lot. I know it's a lot, but do you guys understand, or
I
do
get it.
you got it? How about the others? You guys got it?
I got it, but it's exhausting. It's too long.
It is too long, but guess what? It's
I feel
algebra
like I'm gonna get
2.
used to it.
Yeah, the other problems that I have in here, like look at number 2. This is very similar to the fourth one. It's just like you have to like follow along and you have to be consistent, right? You can't get exhausted. That's the thing. You have like every time you have something that is like contracted in the form of like having a whole square, expand it first, right? Keep everything else same, expand it, and then start to distribute and then combine the like terms, right? And then you guys see how this is already written in standard form, because when they give you this like big questions, they usually arrange it in standard form so that you don't have to do it. But yeah, that is the answer. I believe why Amina was like not getting the right answer is because of this thing right here, right? So every time you have like, let's say x plus 2 to the third power, that just means you are multiplying x plus 2 3 times. And there is a formula. No, there is not a formula for that. But yeah, you have to multiply this like 3 times. Or probably there is a formula. But yeah, there are formulas for the whole square. You can memorize. You can kind of like memorize the formula. If you don't want to do that, then you have to follow this step of like kind of expanding them. I'm like 10 minutes over. I took like 10 minutes of your time.
It's alright.
Do you guys have any other questions?
No.